Okay, so now we're going to take a look, move past one and two step equations into what we call multi-step equations. And often in multi-step equations, what ends up happening is that at some point, you have a situation where you've got like terms, and either the like terms are on the same side or they're on opposite sides. And by same side, I mean same side of the equal sign, either the left or right. And by opposite sides, I mean on opposite sides of the equal sign, some on the left and some on the right. And so what we're going to look at here is those different situations. And I think that it makes sense to you if we don't do this with numbers, if we do these with some other types of symbols. So in this case, we have stars and flowers and some nice smiley faces. So the two situations. One is I've got on the same side. So let's say that I've got a group of 3 stars and a group of 4 stars. And they're on the same side of the equal sign. And so that means that I really have just 7 of those stars on the left-hand side. So let me grab another star here. I've got 7 of those stars on the left-hand side of this. And which then, on the right-hand side, it doesn't necessarily matter what I have over there, but the idea is that I've got 7 stars on the left-hand side. Let me pull down the stuff that I have over here. I have a flower and a smiley face, and that doesn't really matter. But what I'm looking at is that if I'm dealing on just the left-hand side of this, okay, you're just combining like terms. So if I've got 3 stars and 4 stars, that means I've got 7 stars. Okay, on the right-hand side, I didn't have any like terms, and so I didn't do anything with that. Okay, so if they're on the same side, combine them, and we'll look at this in terms of numbers here in a second in our equations. On different sides, if I've got things on the same side again, so like here I've got, in this situation, I've got these 3 flowers on the same side. So that means that I've actually got 3 flowers left over here on the left. So let me grab some flowers. Okay, so I've got 3 flowers on the left-hand side. But if I look, I've got smiley faces on both sides of the equal sign. So if I take off a smiley face from this side, okay, and I get rid of it, and if I take off a smiley face from this side, those two equations are still equal. If I took the same amount from both sides, then they're still equal to each other. Same thing happens here if I were to take off this smiley face and this smiley face. Okay. And it actually turned out that there was another smiley face underneath there that you couldn't see, but it leaves 2 smiley faces on the left-hand side. Okay? And so that's the way that you want to do this set of problems. So I'm still left with 2 smiley faces over here. So I want to say that I've got 2 smiley faces, and then that's going to be equal to, not smiley faced, 2. Equal to the 1 star that I've got on this side, still left over here. And we'll deal with numbers again in a second. But again, I had the smiley faces on both sides. So if I just take them off of both sides, then the equation stays balanced. If they're on the same side, I just want to combine them. Okay. So then let's take a look at that in algebra, math, regular math type terms that we're looking at here. So I've got like terms. So I've got 3 x's, darn stars. I've got 3 x's and 7 x's. The question is, are they on the same side or the opposite side of the equal sign? Well, if I draw that line, that river through the equal sign, then I can clearly see they're on the same side. And so I'm not moving them. I've got actually 10 x's on this left-hand side over here. And so that's combining like terms. That's the first step that I want to do. Get all the x's of the variables together. Now I've got a nice 2-step equation. If you remember 2-step equations, you're good to go. This is the nice, friendly equation that we want. Okay? If you don't remember that, well, look at this. I've got a number and a number. They just happen to both be 2's. Okay, but I've got a number and a number. So if I were to take off the number from the smallest amount of those from both sides. Okay, so if I were to take off 2 and take off 2, then I'm going to keep my equation balanced. I'm just taking them off of the same side. So I've got 10x, 2 minus 2 gives me 0, and 2 minus 2 gives me 0 again. Now I've got a nice one-step equation. 10 times what would give me 0. I will want to divide by 10 to give me x is equal to 0 as my final answer. Okay. On equation or problem number 2, draw the river in. I've got x's on the left, so I just want to combine those. I've got 4x's and negative 6x's. So after I combine those, I've actually still have negative 2x's. Okay. Now I've got, again, a nice friendly equation. If you don't remember how to do the friendly equations, then you can look at it as I've got a number on the left-hand side, the 6, and I've got a plain number on the right-hand side, the negative 6. So if I take away the 6 from both sides, and the reason I'm choosing the 6 is because it's with the variable. I want to get the variable by itself. That's the whole goal here. So the things that I want to get away this 6, and I want to get rid of this negative 2. So things to get rid of are those two things. And the way that I do that is I move the numbers first. So I get rid of this 6 by subtracting 6. So I'm going to subtract 6 from both sides. So I get negative 2x. Negative 6 minus 6 is negative 12. Negative 2 times x. So I want to do the opposite of that, which is divide by negative 2. And I get x is equal to negative 12 divided by negative 2. Negative divided by negative is a positive. 12 divided by 2 gives me a 6. So go ahead. You can work on a few of the rest of these. Number 4 is a pretty challenging one, but if you think about these same ideas, you can get through it. Let's jump down, let's say, to number 8. So I'm going to write out a long version of number 8. So I've got x and then a negative 1 equals 7, which is 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 6 plus 1 is 7 plus x, because 2x is 2x's. Okay? And so if I think about this in terms of taking things away, I want to take away, I've got x's on the same side. So if I take away this x and I take away this x, I'm now left with a nice friendly equation. And you can think about these problems that way. So on the left-hand side, I've still got negative 1. On the right-hand side, I've still got those 7 1s, but I've only got 1x left. Okay. Mathematically, the work that goes into that is I'm going to subtract x from both sides. I've got an x on both sides, and so I want to take it away. Okay, there's 1x on both. There's 2x on one side, but if I only want to take away that smallest number, so I take away that 1x, and I end up with this nice friendly equation. Now the friendly equation, the things I want to get rid of the 1, and I want to get rid of the 7. So to get the x by itself, so get rid of the 7 first by subtracting 7 from both sides. Negative 1 minus 7 is negative 8 is equal to 1x. Now, some of you are going to want to divide by 1, and you can, but what we're looking for is what does 1x equal? And so we've got 1x is equal to negative 8. Number 9, I've got x's on both sides again, except this time I've got negative 6x and 4x. So I want to take off something from both sides, but I want to take off the smallest one because I can't take off more than what I have on the smaller side. And if I did, I would end up with a negative. If I take away more than what I had, it's a negative. Okay? But if I choose strategically what I'm going to take off, so in this case I'm going to take off the negative 6x, because taking off the negative 6 is actually going to give me more numbers up on the right hand side. Take off a negative 6, that means take off a negative 6 minus a minus actually is a plus. So I want to add 6x to both sides, and again, if you draw the river in, these are combining, so I've got 7 still left over here. Negative 6x plus 6x cancel. 4x plus 6x is 10x, and minus 113 is still on the right hand side. Now the things that I want to get rid of, I want to get rid of the 10 and I want to get rid of the negative 13. The negative 13 is the first thing I want to get rid of using SADMAP, get rid of subtraction addition first. So I add 113 to both sides, which gives me 120 equals 10x. To get rid of the 10, I have to divide by 10. And 120 divided by 10 gives me a 12. And that's all of the situations that are going to happen. Now I can make the problems a little bit more difficult by putting a few of those things together, or adding more numbers to it. And that would be in the case of, there was one that I was going to go to, number 16 here. So I've got 16, I've got the x's on both sides again, okay, but I've also got numbers on the same side. So on the right-hand side, I've got negative 10 plus 1. So that's what I want to take care of first. I want to take care of the numbers that are on the same side. So negative 10 plus 1 actually is negative 9. Now I've got x's on both sides, so I've got the, I want to take away the smaller of the two, so that's take away the negative 2x, and I take away a negative by adding. So I add 2x to the left and add 2x to the right. On the left, they cancel, and I get 7. On the right, I get 6x plus 2x is 8x minus 9. Nice friendly equation. We need to get rid of the minus 9 and get rid of the 8. Get rid of the minus 9 first by adding 9. So I get 16 is equal to 8x. Divide by 8 because it was 8 times x, and x is equal to 2. And go through and finish off this worksheet. Okay, it's a good one for practicing variables on both sides, variables on the same side. Same side, just add them or subtract them, do whatever it says. Opposite sides or on both sides, we want to move them, and we move them by adding or subtracting, doing the opposite operation.